So let's start it off. First off, on this test, there's technically two types of questions, and one question has two versions. So let's say three questions. Guys, so for in this case, we're going to do our first one, which is a basic area between two curves. So please tell me the area of y equals x squared plus 2x plus 1. So something like this. 0, comma 1. This is 1, comma 0. 2, comma 1. Thank you. And then I'll do this in red. Y equals 2. Now, it will be graph for you on this test. All right. So I want the area between these two curves. So I want this area in between here. Guys. Hey. Some people have some low class participation and they're getting lower and lower. So in this case, we have this area in between. So what we're going to do is find the integral between two of them. Now, the integral is based off where they both interact. In this case, the intersections of both lines, it's at 0 and at 2. We take the x values in this case. So 0 and 2. We always put the top function first. So in this case, the top function is y equals 2.
Is the top function never going to be the lower number?
What do you mean?
Is it never, like, let's say the top function was 0. Is that possible?
It could be. It would be underneath. I wouldn't do 0 though, but it could be like negative 1. Let's say.
So it's possible, like, for it to be lower than high.
Yeah.
Because we haven't had any so far, so I don't know.
You could have something like this. You're still finding this area, which means this is like negative 3, let's say. That would still be the top function. All right. So 2 minus, always put parentheses here to avoid problems. You're going to put the bottom function, x squared plus 2x plus 1 dx. So from there, we're going to go from 0 to 2, combine like terms, negative x squared minus 2x plus 1 dx. From here, now you're just anti-deriving.
Wait, if you're combining like, oh no, never mind, because the one.
So we're just anti-deriving. So the antiderivative of this is negative x to the third power over 3. The antiderivative of this is minus 2x squared over 2, which means you could kind of cancel those out. So we're just going to put x squared.
Where did the 2 go?
The
big 2.
Because 2 is on top and 2 is on bottom, I cancel them out.
There.
There'll be the end part. Watch. And then
No, make up these
plus x. It shouldn't be in a different color. Plus x. Technically to the 1 divided by 1. And that's going from 2 to 0.
But I mean the 2 up there.
2 here?
The big 2.
This 2?
Yeah.
I combined it with the 1 earlier. So I become a positive 1. 2 minus 1 is 1.
Oh, I think more.
Then you plug this in. Luckily here it's a 0. So that kind of makes it easy. You know the second part's going to be all zeros. So negative 2 to the third power over 3. Minus 2 squared plus 2. So negative 2, and it's going to be negative 8 thirds. Add that all together. That's 4, negative 4, and 2 thirds. So the area is negative 4 and 2 thirds, units squared. You don't have to put any labels or anything. All right. So that's a basic one where it's just like up, down. We could also have a situation where they're kind of horizontal. So let's do something like this, and let's do something like this. So in this case, let's say this is y equals x plus 3. And let's say this is x equals y squared. The green one is x equals y squared. We want the area in between two curves, but in this scenario, it'll be more efficient for us to do it from the y values. So we're going to derive it from the y values, which means we need our equations to equal x. This one already equals x, so that's good. This one does not equal x, so we convert it to equaling x, which means it's going to be y minus 3 equals x. Oh, 5. Did I say 3 or 5? Let's do 3 because I think that, wait.
I just can't tell.
What's the three?
I'm trying to think what would make the easier numbers. Actually, let's do 2, and I think that will be easier numbers along the way. It wasn't a 2, but, you know, revisionist history. Okay, so they both equal x, so now we can work on this. Remember, when you're looking for which one is the top one in this situation, you're always looking to the most right one. That's the most positive in terms of x values. And you're trying to look for where's the farthest from the shortest.
Could you explain why you flip the x around? Like, no, why you move that negative 2 to the y side?
Because if I'm going to look at it sideways, it's kind of like I need a, usually it's y equals x blah, 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 right? That's looking at up and down. To look at sideways, it has to be x equals y blah, blah, blah.
That's why it would be like this.
Yeah. It would be like the previous one. All right. So in this case, I need to figure out from here to here. I'm going this way, right? So the top part would be the most x value, which one's, or the most right, or the most positive. And I'm going to go from here to here, because that'll be the farthest top, and this will be the bottom. So this one, kind of obvious, it will be 0, 0. If you don't know how to find this one, you could find this one by seeing where they overlap. How can we check where two lines overlap? We could do a what kind of thing?
Vertical line.
Derive, anti-derive.
Nah, something even simpler. Algebra 2, Algebra 1.
That's what I said.
What we could do is a system of equations.
What?
A system of equations.
No, I heard you.
Oh. So since this is look equals x and this equals x, I could do y minus 2 equals y squared. Then I could solve 0 equals y squared minus y plus 2. Oh wait, is this possible? Oh.
Should have left it as 3. You should
3 wouldn't solve it either way.
5.
2, no, because they can't get to negative 1 with 2. Let's just say it's like, for example, 3, 5, okay? Let's just do it like that. 3, negative 5, I guess it would technically be. Okay. I have to actually get ones from the book instead of just making them up. All right, so 3 comma negative 5 is our other point. Now remember, we're looking at y values here. So we're going from x to x. But we have to take the, like, example here. When it's dx, we use x values, correct?
Mm-hmm.
So if we're doing dy, we're actually doing y values. This is 1, 1. So with that in mind, which is the actual range? I guess I said this earlier incorrectly for you guys. But which is the actual range that we're going to do? So if we're looking y to y. 1 to negative 5. Because we're looking y to y. So in this case, it's going to be from 1 to negative 5. The top one, which is this purple one, y minus 2, subtracted by
You did that.
y squared, dy. It's 2 in the equation.
So we change it.
I can't in my head make up one that will make it all nice. So let's just pretend this is, for example. So from 1 to -5, negative y squared plus y minus 2 dy. A little anti-derive. You're going to see a lot of them are similar just because I don't want to make them too complicated. So it's usually like a parabola and a line or 2 parabolas. No, we're anti-deriving now. So the antiderivative of this is negative y to the third over 3 plus y to the second over 2 minus 2y from 1 to -5. So let's actually plug in the 1. Negative 1 over 3 plus 1 over 2 minus 2 subtracted by the second part, the -5. -5 to the third power is positive 125, but double negative makes it positive,
But, oh, did
over 3. This is squared. -5 squared is positive 25, so plus 25 over 2. -2 times -5 plus 10. You can either type it all in the calculator or change the base of them. Not that calculator, shoot. This one. So for this one, I'm going to change them all to base 6. So negative 2 base 6 plus 3 base 6 minus 12 base 6 minus, I'm going to distribute the negative, 250 base 6 minus 75 base 6 plus 60. Oh no, distribute the negative, minus 60 base 6. And I could add all the tops. This combined is going to be negative 310, 385, 397, 399, 396. So negative 396 over 6. 396 divided by 6. Oh, wait. Oh, shoot. 396 divided by 6. 66.
That's so messy.
That's what happens when you just make up numbers. Assuming I did that right. Again, if you go, then you're going to be like, I just told me you made that wrong in the video. Know that I did that on my head. Give me a break.
Can we see our grades so we can see how bad we've done the test?
That's what I'm saying. Like,
If you-
so
can
many
you help
times.
me do the math to see what I have to get in order to not like?
Sure, can we do that after the video?
Yeah.
Okay.
Oh, no, it's not.
We have the volume one.
But like, well, I mean,
You know, for college,
For
Aiden,
life.
duh.
Like,
Like, what happens if you get pulled over by a cop?
Life.
And like, is there a problem, officer? And then he goes, yes, solve this.
When have you been in that situation?
Once, actually.
Okay.
But he thought he was being funny.
take out.
Right.
Not
You
just-
got pulled over?
Yeah, never. I'm a good driver.
You've been driving for like only
I
2
just
months.
speed
Pulled
a
over
lot.
because my
Driving for 2 years, this is the law.
Oh, 2 years, my fault.
Yeah, not 2
I've been
weeks.
driving for less than a year, but I've driven more than
All right.
that amount of time.
I want the volume made where,
I've gone 30,000 miles in 10 months. Like this with that.
so I want a volume of this thing, of a horn that has the edge equation of this, for like a parabola, which is y equals x squared. And I want it from 0 to 2. So I'm trying to get the 3D horn shape. I guess see, this is like the opposite of it. That's going around the x-axis, like pivoting around the x-axis.
I can just make the second line. Like, how do you decide?
I mean, I just did y equals x squared to be easy for me. So in this case,
No, I mean the red line.
the red line, I'm telling you it rotates around the x-axis, so I'm trying to draw it. Like, it doesn't really matter the circle itself. It's just help to visualize it. Like, in the black is technically all I have to give you, okay? All right, so in order to do this, we need to think about it. We have some kind of shape here that's kind of like a cylinder or a prism, which is capital B times H. So H is the 3D height. Since the height is on its side, the height is from here to here, or in other words, from 0 to 2. So from 0 to 2, we need our base now. The base is a circle that as you move along x values, could get smaller and smaller, or if you're going the other way, bigger and bigger, you're getting some x values. That makes a circle. A circle is pi r squared, and the radius is the distance between the x-axis to this curve. So because this is between the x-axis to this curve, it's going to be pi times our radius, which in this case is x squared. So from 0 to 2, x pi, x to the 4th, dx. Should have put dx here also. We anti-derive. So it's going to be pi x to the 5th divided by 5 from 2 to 0. Luckily, 0 cancels out everything. So we're going to go get 2 to the 5th times pi divided by 5. 2 to the 5th is 32. So 32 pi over 5. Sure. That help? So remember, for us, it always will be a circle shape. So it's always going to be pi, and your radius is basically your formula at the most simplest way. Hope this helps. If some reason you can't take the test on Monday, let me know and we can figure out a time. Let's close this up.